Good morning, students. How are you? We completed, we completed first unit, right? Now it's time to move second. But I thought instead of moving to second unit, just one session for revision classes, so that automatically, if any Navy user will easily understand the concepts in first unit. Okay. So in this class, we consider a various scenarios in first unit. Starting with first topic is why file and database systems are introduced, why database is used, what are various models in DBMS, and what are various languages, what do you mean by independence, and what do you mean by schema and instance, and important architecture, DBMS architecture, and another structure is called as client server architecture. So in this section we discuss revision of first unit. Okay, coming to first topic, what is a file system? File is a collection of records, but we store data individually, because for example, consider faculty registers. We have 6 faculties in your semester, so all will maintain each register, so that when I say bring all third CSC registers means the department. But when you consider a database is a collection of files which stores data combinedly. That is nothing but, if you take Excel sheet, attendance is a combination of all 6 files, and we maintain these all 6 files into one database. That is nothing but, see here, this is a Excel sheet called as attendance. In this attendance we maintain each and every attendance of each and every subject. For example, this is DBMS, this is another person. So remaining all, we have 6 individual files are combined and integrated into one database called as Excel sheet. Okay, so I hope you understand the difference between the file and database. But we have various drawbacks in file system. Already we discussed. When you study the advantages of database, automatically you can understand what are drawbacks in file system. Okay, in examinations they ask a question like this, that is, explain conventional approach versus traditional approach. The conventional approach is nothing but file system, whereas the database is nothing but traditional approach. Traditional approach means what we are using nowadays. Now coming to the concept called as what is data and what is information and what is DBMS. Already we say that data is any sort of information which is stored in computer memory. Okay, and what the data is a raw material. Based on raw material, that useful data or meaningful data is called as information. Coming to DBMS, it is a software which performs or which interacts with user to system or the database, such that based upon retrieving and recording or storing or retrieving or manipulating can be done by means of DBMS software. Okay, next, coming to a database, it consists of 4 categories called as users, software, hardware, and data. So the users are nothing but different types of users store their data by means of a software called as an application in in your device called as hardware. Okay, this is a persistent data. Persistent data means unless the user modify the data remains in database consistent manner, right? This is the diagram for whatever you discussed database components. We have end users. End users sends the data, request the data what he wants by means of an application called as DBMS, so that based upon DBMS user data moves in database server. So in database server, the data is in the form of metadata. That is all the that is data. Metadata is nothing but data about data. That is organizing the structured data according to the user's request. That is, if the customers are available, all customers data is available in customers database. If there is invoices, all the customers invoices are in particular organized manner. All the customers products are available in a organized manner. So this is nothing but structure database components. Next, coming to difference between a data, information, knowledge, and wisdom. So already we discussed that data is a raw thing, such that based upon raw thing we generate meaningful information. Based upon meaning, the user gets some knowledge. So after getting the knowledge, the user will apply that knowledge. Okay, see, this is an example for I have a red, I have a some IP address, and I have a some area information. Okay, so here one person is moving to one station to another station, such that what he is in traffic, so that when he is in travel, there will be a suddenly stop. So the suddenly stop is based upon the traffic signals. So in the traffic signals is at south facing traffic light on corner of Pitt and George Straits. So the south facing traffic light is a IP address. That is, we in some in area we have in a town we have various traffic lights, right? So among the traffic lights, which light has to blink means that consists of some IP address. Okay, this is the particular south facing traffic light IP address. Okay, but we don't know here. Okay, next, on which area the traffic light belongs means that is corner of Pitt and George. Okay, and there it streets have on that in that street the traffic light turned as red. Okay, so this is a raw data. In that raw data we retrieve some meaningful information. Now what knowledge he get means while he's in traffic it is turned red. Okay, so that he applied his knowledge as so that he stopped his car. Okay, so this is the overall data. Among the overall data he retrieves his location where the traffic light blinks. Among the particular thing, when he when while he's in driving, automatically he sees the red, so that he stopped the car. Okay, this is the information and raw material called as data, and knowledge, and how we apply that knowledge called as wisdom. Okay, next, coming to purpose of database system. So already we discussed that there are very drawbacks available in file system. The drawbacks can be overcome by means of what we call as database system. So in this system, we have data redundancy problem is overcome. That is, in file system the duplication of data is available, whereas in database system the duplication will not be available due to integrity constraints. We maintain some integrity constraints. Based upon integrity constraints, redundancy problem will overcome. Next, inconsistency problem. That is, we have various data lies in various format. So each format maintains its data, but in database all different formats comes under one format called as structured format. Okay, next one is difficulty in accessing data. In file system there is a difficulty for accessing the data, whereas in DBMS or the database there is no problem for accessing the data, because we use particular commands called as DML. Based upon DML we can retrieve very fastly. But have atom acid properties called as atomicity, consistency, that is here consistency, next isolation and durability. So all these acid properties are comes under the transaction management, because when we transfer money from one person to another person, there will be some problems called as when the power failures, or while in a transaction the data is lost, meanwhile in transaction data is lost. So all these problems comes under this transaction management. So in database, these transaction management can overcome the above problems. Next, concurrent access. So concurrent access means in file system, two or more persons will not access same data because there will be a one user for retrieving the data. Whereas in database, we have concurrent users can access the data by means of their particular database structure. Next one is security problems. So already we discussed that if in file system our register file is lost, automatically we have to maintain next register. That is nothing but the data will be again we are maintaining, such that we in database we use some security features called maintaining or creating username and password, so that no other users or no theft is happened in accessing the data. Okay, so these are the different advantages. These are the different advantages while we are using the database structure. Okay, next, coming to the various models. These are the various models for creating the database structure. Okay, first of all, we use a structure called as model called as hierarchical model. In this hierarchical model, data is in the form of tree. The drawback here is when there is a parent node is lost, automatically all the data is lost. Next, hierarchical model, we move to the network model. In network model, data is organized in the form of graphs, so user can easily access the data. But at a time, only one user can access the particular data. If there is a more number of relations available in the particular network model, we cannot access the data. Next, based upon this data, this problem, we move to the ER model. ER model is a logical structure data or logical schema data, where data is in the form of entities and attributes. It is a pictorial representation or pictorial representation, where entity is nothing but real world thing, that is nothing but a student has properties called name, address, age and id. And moving to the in this, the relation is easily understand because the data can used in picture format. Now coming to the number of data where we are accessing can be based upon relational model. In relational model, data is in the form of two-dimensional, that is a table format. So we maintain relation from one table to another table. But in real world, all should be implemented in object manner. So object to object relation is done in object oriented model. So DBMS deals with relational model. After giving the ER model logical structure, the ER model data can be implemented by means of relational model. Okay, we will discuss this one in second unit. Okay, next, database languages. For creation of database, we use two types of languages called as DDL and DML. DDL is nothing but data definition language, which defines the schema, and DML is nothing but to retrieve the data in schema. So DDL commands use create, alter, drop. DML commands use insert, delete and update. So for inserting data, deleting data, for updating the data in relational database, we use DML. For creating the schema, altering, adding column, removing the particular table, we use DDL command. But in DML command, we have two types of languages called as procedural and non-procedural. Procedural procedural language is nothing but which has to specify by the user what to do and how to get the data. Whereas in non-procedural, only he specify what data has to take without specifying how to get those data. Next, coming to the our topic called as relational database management system, we have various terminologies called as table, field, record, or row, column, null value, and degree of the relation and cardinality. Table is nothing but two-dimensional structure where which consists of rows and columns. Field is nothing but in the table where the data is lies under attribute called as field. Record is nothing but the The overall row of particular table is nothing but recorder row. Column is nothing but particular attribute information has to be taken by user. The particular attribute information is called as column. So this is the table, this is the field, 1 2 3 4 5 fields. Row consists of 1 2 3 4 5 6 7 rows. Individual row is called as record or row or tuple. Okay, next column is nothing but particular field data is nothing but column, and null value is nothing but if there is no data available in the table, we represent that data as null value. For example, here we have a quota, so that there is no information called quota, then the user will represent the quota as null value. And degree of the relation, so total number of attributes in a relation schema is degree of relation. We have 1 2 3 4 5 in our relation. 5 fields or 5 attributes are available, so 5 count is nothing but degree of relation, and relation cardinality is nothing but total count of the rows in a relation. We have 7 rows in our relation, so cardinality is 7. So already you know that degree of the relation is nothing but total count of columns. Relation cardinality is nothing but total count of rows in a relation. Okay, next, coming to independence. Independence is nothing but when the user retrieves the data from the database, he has to follow some steps. That is nothing but user is the one step. User sends his data in a high level language. That high level language is taken by the conceptual schema. In conceptual schema, data is in the form of table, and after conceptual schema, the table format, it is moves in a physical format, that is nothing but data dictionary and metadata format. So while we are moving from one level to another level without affecting one level to another level, that concept is called as data independence. But when we are accessing from one level to another level, if there is any changes happen in particular level, it should not be affected to another level, is called as data independence. We have different types of data independence, called as two types of independence, called as logical data independence and physical data independence. Logical data independence is nothing but whatever we are changing at a conceptual schema or logical schema, it should not be affected to physical level. That concept is called as logical data independence. Physical data independence is nothing but whenever we are changing the particular physical database, it should not be affected to conceptual schema. That particular concept is called as physical data independence. Okay, I hope you understand. But we have 3 levels, called as, this is a 3 level architecture. First is user level or external level, conceptual level, and physical level. External level, nothing but where we have more number of users to retrieve his data. He doesn't want overall data, he wants only particular instant of the data. So he gives command to the conceptual schema. Now conceptual schema takes the user data and takes that data is in the form of table, and that actual data is in the form of what we call as data dictionary. Now he checks the data and checks in the table and give to the physical schema. Now physical schema checks that user data and retrieve data from any metadata, data dictionary, or any catalogs, or any indexing. By means of indexing, the data will be given to again conceptual schema. Now conceptual schema checks the data and given to the different users. This particular concept is called as 3 level architecture. Okay, next, already we discussed. Next, we have database schema. So the database schema is nothing but logical view of entire data structure, and logical view is nothing but this is the logical view. Okay, okay, next, how the data is organized. Here the data is organized in logical schema and physical schema. In logical schema, the data is organized in the form of tables. In physical schema, the data is organized in the form of data dictionary or metadata or statistical data. Okay, next, database instance. At a particular time, user wants something from the database. That something is called as instance. Okay, I hope you understand. Next, database architecture. Already you discussed this database architecture. We have various types of users called as naive users, application programmers, sophisticated users. Naive users don't anything else. Application programmer only knows the particular coding languages except database. Sophisticated users knows the only database languages, and DBA is the performer which performs monitoring from his command from high level to low level. He is the complete authorized person for accessing the data by the user request. Okay, he acts as a security person. Next, coming to query processor, we have three things called as compiler, evaluation engine, and parser. These are the parser. Okay, parser is nothing but the high level data can be taken by the parser and checks whether the data has syntax and semantics meaning or not, and checks whether is a check hard pull or soft pull. That is nothing but pooling concept. Based upon the soft pull, directly goes to the database and return data and given to the user. If it went to the hard pull, it checks in a query evaluation engine. The query evaluation engine is nothing but already data is in the form of relational algebra. So the data can be retrieved by more number of users, so concurrent executions are happening. So based upon concurrent execution, the query evaluation gives which has the least count of time among all the concurrent execution. Based upon particular count of time, less count of time, the query evaluation engine will take the data and given to the user. And next, coming to the storage manager, it has four components called as, if it is your security mechanisms, then authorization and integrity manager will perform. If any transactions called as asset properties, next transaction manager will act as, will perform. If there is a data coming from secondary to main memory, then buffer manager will perform. Asla whether the data has memory or not, that can be maintained by the file manager. And last one is database level. And database level, we use a performance called as indexing. Based upon indexing, the data can be retrieved very fast. And data dictionary consists of metadata, and statistical data consists of OLAP and OLTP. And next one is another structure called as client server structure. In the client server structure, all the workstations or the PCs are connected by means of the network. So in the client server architecture, we have three categories called as 1 tier, 2 tier, and 3 tier. In single tier architecture, the device consists of the database, so that if any changes is happened, automatically it is affected. So coming to the next level called as 2 tier architecture, in that client uses his application, but server doesn't have any application. User communicate indirectly by means of application. Application can directly go to the database based upon these two has the same language. These two has the same language like JDBC and ODBC connection. So that the server will return data to the user. Here also no problem. If more number of users are accessing, there will be a problem. So that we go to the 3-tier architecture. There the user uses his application, server uses their application. Based upon applications, indirectly communication can be happened from user to the database. So this is the architecture nowadays we are following. Okay, next, this is the last topic of your class called as, already we have not discussed this topic called as distributing processing. So distribution processing or distributing processing is number of users are asking, if our same user asking different process. Now the distributing processing has a capability of dividing the task that was assigned, that was asking by the user, and giving the individual task to the user. This is called as distributing processing. That is, here there are two types of distributed processing. If see this example, there are more number of clients are accessing by the network to a single database server, but one client access his application, he has a task, and second client accessing the network with different task. So more number of clients are accessing the network with the different tasks. Now, the distributing processing has a capability of dividing each task to the each clients. Okay, in this one, see here, the client in this example, the client and server are located on different computers. So these computers are connected with a network. Now coming to second diagram, a single computer has more than one processor. For example, in the top, which consists of two or more processors retrieving the server. Now the server divides the tasks and given to the user, to a single user. Simply we discuss this concept by a person consists of a laptop. In that laptop, he is retrieving three or more applications. So three or more applications or three or process can retrieved by a particular single server. Okay, this is the concept of distributing process. And last one is context models of data models. So already we discussed that we have, okay, for mapping the levels, we have four categories called as one to one to many to one, and many to many. For examples, a single row of first table associate with single row of second table. That is, for example, I consider a student table. In student table, and second table is a passport table. Every student consists of single passport. Okay, there is no two or more passports to a particular student. So this is a one-to-one relation. Second one is one-to-many relation. A single row of first table associate with more than one rows of second table. This example can explain as if a single person orders different items. Okay, one single person orders different items. Okay, it may possible. Okay, so we take a one customer table, second one is a order table, so that one customer will take two or more orders at a time. Okay, items at a time. Many to one means many rows of first table associated with a single row of the second table. See, this is the example. You consider a student relation and university relation. Okay, the more number of students are comes under single university. Okay, and last one is many to many relation. So many rows of first table associate with many rows of second table. That is, in any organization, many more number of students are opt the either PG or either UG or either diploma. So many students are opting many branches. So this is the concept of mapping the levels. All the lecture videos are made previously. So if any doubts, visit that one. Okay, this is only just recall. Okay, if any doubts regarding particular topic, check the previous YouTube versions. Okay, I hope you understand the complete first unit. Okay, thank you so much.